In this video, let us continue to solve more problems based on parabola. Alright, here is the question which reads like this. It says find the equation of the parabola which is symmetric above the y-axis and passes through the point 2, minus 3. So what does this mean? What is this data trying to say? Symmetric above the y-axis. So say first of all, let us try and draw this parabola that is mentioned in the question. All right, something like this. This is, of course, y dash, and this is x dash x. What do you mean? What does it mean when they say symmetric above the y-axis? I mean, it's got equal half on both sides of the y-axis. That means the vertex of the parabola lies on the origin of the rectangular coordinate axis. That's what it mainly means. That's one thing. But we do so. I mean, when they say it is symmetric above the y-axis, we are sure that it has to be either upwards or downwards. It can't be sidewards, because sidewards it can't be symmetric above the y-axis. It has to be symmetric above the x-axis. So that's one data that you get from this. When they say symmetric above the y-axis, you get to know, is it a sideward opening parabola or is it an upward or a downward opening one? So we know that it can be either the upward or the downward, because we do not know where exactly it is, because we've got limited data. And by this symmetric above the y-axis, we come to know that the equation has to be either x square equals 4ay or x square equals minus 4ay. This will be x square equals 4ay and this will be x square equals minus 4ay. Now, how to determine that one, we will see in the next data. And it also says it passes through the point 2, minus 3. And where does 2, minus 3 lie? 2 is the x coordinate and minus 3 is the y coordinate. This is positive, positive. This is negative, positive. This is negative, negative. This is positive, negative. So this 2, minus 3 has to lie in the fourth quadrant, right? Because in the fourth quadrant, x is positive and negative 3, which is y coordinate, is negative. So it has to be in the fourth quadrant. If the parabola passes through the point 2, minus 3, that obviously shows that it has to be the downward equation. I mean, it has to be the downward curve. It can't be the upward curve. Upward curve cannot pass through this point. So therefore, we conclude that this is the equation. This is the type, or this is the form of parabola we are looking at. So let's confirm that it is x square equals minus 4ay. So now that we've confirmed it is x square minus 4ay, we need a, right? Now, how do you find a? They say that it passes through the point 2, negative 3. So all we have to do is just substitute 2, negative 3 in this equation. We get 2 square equal to minus 4a times minus 3. So 2 square is 4, equal to minus 4 into minus 3 is 12a. So a equals 4 by 12, which is 1 by 3. Now that we found a, we can substitute a in this equation and find the equation of the parabola. That's all. So we have x square equals minus 4 times 1 by 3y. So we have, let's multiply throughout the equation by 3. We get 3x square equal to minus 4y. So therefore, the equation that is required is 3x square minus 4y. Well, this problem wasn't as straightforward or as simple as the problems that we've solved in the previous videos. But here it was a little indirect, I would say. The words like symmetric about whatever axis tells that what kind of a curve that is. Is it going to be opening left side, right side, or top or bottom? So that is one thing you can find from this. But you can't find the specific thing. You can only find out if it is going to be upward or downward, or right side or left side. You can't find out the one. So to find out that, you need to see the point through which the curve passes through and then locate that point, which quadrant it's going to be. So based on the location of the quadrant, you can say if it is upward or downward or whatever that is, right? So after that, we need a. So to find a, substitute the values of x and y in the equation. And once you found a, substitute the a back in this equation to get the equation of the parabola in question. All right. So that ends this problem as well as this video. I'll see you in the forthcoming videos with more problems based on parabola.